Hello my dear, this is Ujjwal Kumar Sen. Again I am back with another question, and this is a question for simply supported beam. Simply supported beam, and here I have taken in this question UDL. So this is one of the important question for university examination point of view as well as competitive examination point of view. How to solve question when you are giving point load as well as UDL load in simply supported beam. This is important. This is really most important for any examination point of view. Well, I'm from India, and I usually have seen question in this topic around 20 marks and for a single question. And I have seen few university they are setting question like this only for 20 marks. So this is really important. So let me share with you how you can solve this type of question, and you will come to know, and you can do the same if you will keep watching. So keep watching and keep listen to me carefully what I am talking in this video to solve this question. So let me first extend these lines. That's why I can draw shear force and bending moment diagrams for this question. So I'm taking this is as a reference line, this as a reference line, and here I'm going to draw shear force diagram. So first of all, I have to find out reaction force. Here let me take reaction force A, and here let me take reaction force B. So total force acting on this beam is equal to total reaction force. That's why we can write RA plus RB is equal to total load. So this is 30, this is 20, because this is UDL, that means 5 kilonewton per meter. So total load acting on this because of this UDL would be 5 into 4. So 30 plus 20 plus 20. So total load would be how much? 50 plus 20, 50 plus 20, 70 kilonewton. So this is important. Now let me total load acting on this beam 70 kilonewton. So total reaction force would be 70 kilonewton to balance this beam. So let me find out how much load, how much reaction force is acting here and how much reaction force is acting here. So let me share, or let me assume that RA is fixed. I am assuming here RA is fixed. So if I will assume RA is fixed, next what will happen? We can write a equation that I am just writing here only. So RB into total length of this beam, that is 10 meter. 4 plus 4 plus 2 is equal to 10 meter, is equal to 20 into total distance from here to here. So 20 into 6 plus 30 into 2. So how much would be this? 120 plus 60, 180. And total acting load, I mean also we have UDL load. So bending moment because of this load would be 5 into 4 into, because this load will be acting here, so 4 by 2 distance plus 2. So total would be 180 plus 20 into 4, 80. So total bending moment here would be 260 kilonewton meter. So RB is equal to 260 by 10. 260 by 10 is equal to how much? 26 kilonewton. So total reaction force would be here 26 kilonewton. If RB is equal to 26, then RA is equal to 44. Simply I have just do one thing. 70 minus 26. 70 minus 26 is equal to 44 kilonewton. So this would be 44 kilonewton. Now I have to draw shear force diagram. So here what I have to do, here we have 26 reaction force, that means this will be 26 because this is negative here, 26 kilonewton. Now here we have again adding here 20, that means minus 6 remaining. So and here we are having UDL, so that's why 20, 5 into 4 20 minus 6 would be how much? 14. So this would be like this this is 14, and 14 plus 30, 44, and this its unit are kilonewton, it's also kilonewton. Now what we have to do, we have to check it, is it right or wrong? Just add minus 26 plus 26 is equal to 0. That means this is right. Here 44 plus minus 44, that means this is right. So we have to check it whether it is right or wrong. Now on the basis of this SFD diagram, I can draw bending moment diagram. So let me share with you how you can draw bending moment diagram. So here is that. This is for bending moment diagram. Oh, there is a problem. Let me. So how there is a problem with my camera. Okay, no problem. I can show you how we can draw a bending moment diagram for this question. So this is bending moment diagram. Now here we have to find out area of this one, and area of this one, area of this one, area of this one. Now first I have to find out the distance covering here. So what we have to do, total load is acting here, that is heavy. Now sorry for the disturbance. Okay, no problem. Now let's come to the back to the question. First we have to find out the distance here we are covering. So 14 kilonewton. Okay, so 14 kilonewton, and here how much distance will cover, that's why it will get 14 kilonewton from here. That means 6 plus 6. So how much distance it will cover to get 6 kilonewton? So 5 into 1.2 is equal to 6. So this is 1.2, and this is remaining how much? Total is 4. So this would be how much? This would be how much? 2.8, because 4 minus 1.2 is equal to how much? 2.8. So this is like this, you can easily find out. Now I can do quite easily. So another basic concept you need to follow. What is that? Let me show you. Let me share with you. So what is that? This bending moment diagram, you need to start from where you have made it fixed. Where I have fixed, let R is fixed, this is fixed, this side is fixed, this one is fixed, I have assumed. So I have to start drawing bending moment diagram from this side only. So how to find out area of this? Maybe you have watched my previous videos. To draw bending moment diagram, we need to find out area. So how much area of this? 44. 44 is height, so this is 44, this is 44, and the length of this is, this length of this beam is 2. So how much would be value? 44 into 2, 88. We need to find out area of this triangle. So rectangle, this is rectangle, and so what would be here? And one more thing, if this is straight line, we have to make it inclined. So this is 88 kilonewton meter. 88 kilonewton meter. Now another thing, we need to find out triangle, the area of this triangle, that is 14 into 2 into 1.2. This value is 19.6. So 19.6 plus 88 is equal to how much? Is equal to 107.6. So this would be let me draw a line here. So this will be this is inclined, that's why it will become parabolic. So this is 107.6. Now this is positive, that's why I have added with this. This is in negative, that's why I have to minus this. We have to find out area of this triangle. So 1.2 into 6 into 1 by 2 is equal to how much? I have to get 3.6, because this is 3, so 3.6. So this is minus 3.6 would be how much? 104 kilonewton meter. Remember, the unit for bending moment diagram is always, this is universal constant, that is kilonewton meter. Now 60. We need to find out area of this rectangle, that is 26 is height and 4 is, this is length. So 26 into 4 how much? 104. So 104, this is negative, this is positive. So negative plus positive, 104 plus and minus 104 would be 0. So bending moment would be here 0. So this is the way how you can find out, or how you can draw bending moment diagram for this problems for simply supported beam in the case of UDL. Well, I hope you got it how to solve question related to it, and thanks for watching. And if you got any question in this topic, let me know. I will definitely share with you how to solve question. Well, thanks for watching. Hope to see you again in my next video. Bye bye.